Right now, far beyond our reaches, an ancient cosmic probe travels through uncharted deep space where no human eyes have ever looked. This small spacecraft moves continuously through a mysterious region that modern scientific models failed to accurately predict or properly explain until now. It is not a modern creation, having launched decades ago before personal computers or the internet ever existed in our daily lives. Operating on a tiny power output smaller than a simple household light bulb, this machine sends crucial data across billions of miles. Designed originally for a brief 5-year mission, this immortal vessel is now revealing facts that shake our understanding of physics. Leading researchers studying these incoming signals are astonished by unexpected cosmic phenomena that completely contradict long-held scientific theories and beliefs. Beyond the headline news lies a profound discovery that directly relates to the long-term survival of all life on Earth. Critical events occurring in deep space right now are reshaping our cosmic perspective in ways few people currently comprehend or discuss. Upcoming orbital milestones set to happen in a few short months will mark an unprecedented moment in human space exploration history. Prepare to view the starry night sky with a fresh sense of wonder as we uncover secrets from the edge of space. Let us travel back to September 1977, when a powerful rocket lifted off carrying a small probe on a historic journey. The original trajectory plan was basic, designed only to fly past Jupiter and Saturn, gather planetary data, and then drift away. Engineers anticipated a short lifespan, expecting the mission to conclude after 4 or 5 successful miles. Years of active space operations. Instead of fading into silence, the small spacecraft defied all expectations and continued its journey far beyond the planned limits. Flying past Jupiter in 1979, it captured the first detailed close-up images of the giant gas planet ever seen by humanity. Continuing toward Saturn, the probe utilized planetary gravity like a gravitational slingshot to gain tremendous speed for its journey onward. By the late 1980s, the craft had traveled farther from Earth than any manufactured object in human history, while still sending signals. Decades after launch, its aged instruments continued functioning reliably, leaving modern space engineers utterly amazed by its incredible durability. Then in 2012, 35 years into its mission, the spacecraft reached a momentous boundary known as the heliopause. The heliopause represents the outer physical edge of our solar system, separating our local cosmic environment from true interstellar space. Our sun continuously releases a powerful stream of charged particles known as the solar wind, blowing outward in all directions. This solar wind forms a giant protective bubble surrounding all planets, moons, asteroids, and living organisms within our solar system. Where the solar wind finally loses force against the pressure of interstellar space lies the boundary line of the heliopause. Everything contained inside this massive heliosphere shield belongs to our home system, while everything beyond belongs to the galaxy. In 2012, the probe successfully crossed through this boundary, becoming the first human object to enter interstellar space. Floating inside the cold, dark void between stars, the probe continues gathering data from a region never directly sampled before. Scientists had long relied on complex mathematical models predicting that interstellar space would be smooth, quiet, and largely static. Theoretical physics suggested that the interstellar medium would act like a serene cosmic waiting room with very low particle activity. However, incoming telemetry from the probe revealed a shocking reality that completely disproved these traditional scientific assumptions. Instruments on board detected persistent plasma wave oscillations, indicating that interstellar space was turbulent rather than calm and empty. A continuous hum in the plasma fabric was registered across hundreds of millions of miles of deep interstellar space. This endless signal spanned a distance 10 times greater than the total measurement between planet Earth and our central sun. Researchers publishing in top scientific journals concluded that the interstellar medium possesses intricate structures at every observable scale. The region beyond our heliosphere is dynamically active, filled with unexpected energy movements that were previously invisible to science. Discovering this turbulent interstellar environment forces scientists to reevaluate how effectively our heliosphere shield protects our planet. The heliopause acts as an essential cosmic armor, deflecting dangerous, high-energy interstellar radiation away from inner solar orbits. If this protective barrier were significantly weakened, harmful cosmic rays could threaten biological life thriving here on Earth. Understanding the true density and energy of interstellar space is therefore vital for predicting long-term planetary habitability. In late 2023, after decades of flawless operation, the aging spacecraft suddenly encountered a near-fatal technical crisis. Telemetry received on Earth turned into unreadable gibberish, corrupted binary code that flight engineers could not initially interpret. Although the propulsion and power systems remained active, the scientific data stream had become entirely garbled and useless. Investigation revealed that a single vintage memory chip had degraded due to 46 years of cosmic radiation exposure. Fixing a broken electronic component located billions of miles away presented an unprecedented challenge for deep space engineers. Radio signals moving at light speed required 22 hours to reach the craft, creating a 44-hour response cycle. Every diagnostic command transmitted carried immense risk, as a single error could permanently end communication with the probe forever. Working methodically for months, engineers devised a brilliant plan to relocate corrupted code to functioning memory chips. This delicate remote operation was successfully completed, restoring clean scientific telemetry from the edge of the solar system. Resuming data transmission, the probe once again confirmed the existence of mysterious plasma oscillations in interstellar territory. Recovering from near death, the venerable craft continues providing valuable observations about the environment surrounding our cosmic home. Yet its most terrifying discovery occurred back in 2012, at the precise instant it crossed through the heliopause boundary. Scientific models had long predicted a smooth, gradual transition where solar particles would slowly thin out into the interstellar void. Instead of a peaceful boundary, the probe encountered a violent region packed with highly energetic charged particles moving at high speeds. Particle collisions at this turbulent edge generated localized kinetic temperatures reaching nearly 30,000 degrees Celsius in deep space. Some astrophysicists described this intense boundary layer as a wall of fire protecting the inner solar system from cosmic rays. Simultaneously, magnetic field measurements recorded at the crossing revealed an unexpected physical link between solar and galactic magnetism. Existing theories predicted two distinct, isolated magnetic environments, cleanly separated at the outer limit of our sun's influence. Instead, instruments detected magnetic reconnection, a dynamic process where solar and galactic magnetic field lines connect and exchange energy. This magnetic linking implies our solar system is far more connected to the broader galaxy than scientists ever previously realized. Now, in 2026, the mission enters its critical final chapter as remaining power supplies slowly reach absolute minimum levels. Earlier this year, mission controllers were forced to shut down the low-energy charged particle instrument to conserve precious electricity. This difficult operational choice was necessary because the radioisotope thermoelectric generators lose roughly 4 watts of electrical output annually. Fueled by decaying plutonium-238, the aging generators now produce less than half of their original launch day power capability. By the early 2030s, electrical power will inevitably fall below the minimum threshold required to operate any scientific equipment. Of the original 10 scientific instrument packages on board at launch, 7 have already been permanently deactivated over past decades. Deactivating an instrument means losing specific measurement capabilities forever, as no command can reactivate a depowered cold sensor later. Yet, flight engineers are currently testing a daring new maneuver internally designated as the High-Efficiency Power Redistribution Procedure. This experimental software procedure attempts to squeeze additional electrical capacity from onboard systems currently operating at lower efficiencies. Because manipulating power on a 50-year-old spacecraft carries extreme risk, initial tests are being executed on its twin craft. Scheduled throughout mid-2026, these critical system tests on the sister probe will determine if the risk is acceptable. If successful, the identical power procedure will be transmitted to our primary probe in an attempt to extend its lifespan. Should this high-risk maneuver succeed, engineers might even reactivate the recently shut down charged particle sensor once again. Meanwhile, a historic astronomical milestone is already locked into the celestial calendar for late November of this year, 2026. On November 18, 2026, the spacecraft will officially reach a physical distance of exactly 1 light day from Earth. At this monumental distance, a radio signal traveling at the absolute speed of light requires 24 full hours to arrive. Sending a single command on Monday morning means flight controllers must wait until Wednesday morning to receive a confirmed reply. No manufactured object in human history has ever traveled this vast distance while maintaining active two-way communication with Earth. Traveling at 38,000 miles per hour, the vessel continues penetrating deeper into the boundless, dark interstellar realm. When electrical power eventually depletes entirely, the probe will not stop moving due to the absolute lack of atmospheric friction. Mounted securely to its metallic hull is a golden record carrying a curated message from human civilization to the universe. This gold-plated copper disc contains spoken greetings in 55 languages, natural sounds, and diverse musical compositions from Earth. It also features precise pulsar maps detailing the exact location of our Sun within the vast Milky Way galaxy. Designed as a cosmic message in a bottle, this artifact will outlast all physical structures ever built upon planet Earth. It will drift endlessly through interstellar space long after our central sun expands into a red giant, consuming inner orbits. Long after human cities fade into geological dust, this silent messenger will carry proof of our species' curiosity across space. Currently, the persistent plasma emission detected by the probe provides humanity with its only real-time interstellar weather feed. Before these continuous measurements began, scientists could only capture isolated snapshots of interstellar conditions during rare solar eruptions. The ongoing telemetry reveals that interstellar space possesses complex dynamic weather system characteristics built from charged plasma and magnetism. The space between star systems is far from empty, acting instead as an active, structured environment with distinct physical traits. Scientists currently debate two competing physical theories regarding the exact nature of the persistent plasma hum being detected. Determining which theory is correct requires either continued data from our aging probe or an entirely new interstellar mission. However, no successor interstellar spacecraft is currently funded, built, or scheduled for launch by any global space organization. Any new interstellar probe launched today would require at least a quarter century just to reach the heliopause boundary. Therefore, when our current probe finally goes silent, humanity's direct observational window into interstellar space will close completely. That inevitable silence approaches steadily as onboard electrical power continues its irreversible yearly decline toward absolute zero output. Someday in the early 2030s, the final scientific instrument will power down, sending one last transmission across space. That final signal will travel 24 hours through the void before arriving on Earth, marking the end of active transmission. Afterward, the silent probe will wander forever through the cosmos at 38,000 miles per hour, carrying its golden message. Operating on 4 tiny watts of power, this retro machine, built in 1977, continues rewriting our fundamental understanding of physics. It possesses the ultimate courage to keep traveling farther than any machine before, unlocking truths from inside the interstellar ocean. As long as its faint signal reaches Earth, we must listen closely to the final secrets transmitted from the edge of space. Entering the second chapter of our interstellar journey, we examine deep space phenomena that continue challenging modern astrophysics theories. The mysterious wall of fire detected at the heliopause remains one of the most intense energy zones ever measured by science. Temperatures reaching 30,000 degrees Celsius create a chaotic thermal environment that baffles researchers studying long-term cosmic radiation. Highly energetic particles collide continuously at this outer threshold, forming a protective shield that buffers our entire solar system. Beyond this fiery barrier lies the true interstellar medium, an active environment governed by complex magnetic reconnection and cosmic forces. Solar magnetic lines streaming outward from our central star intertwine directly with the magnetic field of the wider Milky Way. This unexpected magnetic link demonstrates that our solar system does not exist in isolation from the rest of the galaxy. Energy exchanges taking place at this dynamic boundary layer may influence long-term space weather affecting interplanetary atmospheres. As we navigate through 2026, engineers face the delicate task of managing dwindling power reserves on this aging probe. Deactivating non-essential hardware has prolonged operations, but available power decreases steadily by 4 watts every single year. The decay of plutonium-238 inside the thermoelectric generators sets an absolute physical expiration date for all onboard communication instruments. Mission controllers must carefully balance remaining electrical current between flight systems and vital deep space. Scientific telemetry sensors. Shutting down the low-energy charged particle detector was a painful decision, required to keep primary transmitters operating through 2026. However, the experimental power redistribution procedure currently being tested could potentially unlock hidden electrical capacity from secondary systems. Initial trials executed on the twin spacecraft Voyager 2 provide critical safety data before attempting the maneuver on Voyager 1. If these mid-2026 software modifications prove successful, operators may restore power to recently disabled scientific measurement sensors. Extending active scientific operations even by a few additional months allows unprecedented measurements of the interstellar medium's density. Meanwhile, all eyes remain fixed on November 18, 2026, when the vessel reaches an unprecedented 1 light day distance. Crossing this threshold means a radio signal traveling at 300,000 kilometers per second takes 24 hours to arrive. Completing a full round-trip communication cycle requires an extraordinary wait time of 48 hours for ground controllers. No human artifact has ever operated at such an immense physical distance while remaining actively connected to Earth command centers. Moving at 38,000 miles per hour, the craft steadily leaves our planetary neighborhood further behind with every passing second. Even after its atomic power supply inevitably dies, Newton's first law of motion guarantees the probe will continue moving indefinitely. Free from atmospheric drag or gravitational capture, the silent vessel will wander endlessly through the dark star fields of space. Attached securely to its structure is the Golden Record, an indestructible artifact constructed from gold-plated, copper, and protective casing. This cosmic time capsule contains encoded analog audio tracks, capturing natural planetary sounds, human speech greetings, and cultural music. Etched onto its cover are mathematical diagrams explaining basic physical constants and pulsar references, mapping Earth's precise galactic coordinates. Intended as a message in a bottle cast into the cosmic ocean, it represents human curiosity reaching out to unknown civilizations. Millions of years from now, when human cities have crumbled to dust, this record will remain intact in deep interstellar space. It will drift safely through the galaxy long after our sun expands into a red giant star, swallowing interplanetary orbits. Whoever discovers this ancient vessel will learn that a curious species once thrived on a blue planet near a yellow star. Returning to present observations, the persistent plasma hum detected since 2017 offers continuous measurements of interstellar plasma density. Prior to these readings, scientific understanding of interstellar space relied upon occasional plasma shocks generated by massive solar eruptions. These rare events provided brief glimpses, but could not reveal the baseline structure and daily weather of the interstellar medium. Now, continuous telemetry reveals complex plasma turbulence, proving that interstellar space possesses detailed physical texture at all scales. Charged particles and magnetic fields interact dynamically, creating a living interstellar environment far more complex than ancient models predicted. Researchers remain divided between two competing physics theories explaining the origin of this persistent narrow-band plasma oscillation. One theory suggests thermally excited plasma oscillations, while the other proposes quasi-thermal noise carrying detailed temperature signatures. Settling this fundamental scientific debate requires either additional telemetry from our craft or a sophisticated next-generation interstellar mission. Regrettably, no successor interstellar spacecraft is currently funded, under construction, or planned for launch by any global agency. Any modern probe launched today would require over 25 years just to travel from Earth to the heliopause. Consequently, when our current vessel eventually ceases transmission, humanity's direct window into interstellar space will close for decades. Power levels continue their steady decline, bringing us closer to the final moment when electrical output drops below operational limits. Sometime in the early 2030s, the final active instrument will power down, sending a parting radio signal toward Earth. Traveling 24 hours across space, that signal will mark the official conclusion of history's most successful space exploration. After active communications end, the silent machine will continue traveling at 38,000 miles per hour into endless darkness. Powered by just 4 watts of electricity, this 1977 spacecraft has permanently transformed humanity's fundamental understanding of the cosmos. It demonstrated the extraordinary bravery of human engineering, pushing past known limits into the unexplored ocean between star systems. As long as its faint heartbeat continues reaching Earth, we must pay attention to every piece of data transmitted back. Thank you for journeying with us to the edge of space, and remember to subscribe for more deep space exploration. Beyond the scientific numbers and technical telemetry lies a profound testament to the indestructible spirit of human curiosity and exploration. Launched from a small blue world, this humble machine has outlasted every expectation, carrying our civilization's legacy across billions of miles. Millions of miles behind it, the inner solar system rests peacefully inside the protective heliosphere shield that nurtures all terrestrial biology. Every measurement returned by its aging instruments helps us understand the delicate balance between our star and the galactic environment. While engineering teams monitor its remaining power reserves, every single byte of incoming data is called preserved for future scientific generations. The impending silence of its transmitters is not a tragic defeat, but rather the triumphant completion of an immortal cosmic odyssey. When the final signal fades, our silent ambassador will transition from an active scientific instrument into an eternal interstellar monument. Drifting silently through the vast, dark gulfs between stars, it will carry humanity's story far beyond our own solar lifetime. The golden record attached to its frame remains a timeless message in a bottle, waiting patiently across cosmic timescales for discovery. Embedded upon its surface are our laughter, our music, our scientific achievements, and our eternal desire to reach out to the unknown. Far in the distant future, another intelligent species may intercept this artifact and realize that they were never truly alone in space. They will gaze upon the pulsar map, decipher our mathematical language, and know that a courageous civilization once reached for the stars. Even as the sun eventually transforms into a fading red giant, our metallic vessel will continue its journey completely unharmed. It stands as the most permanent physical creation in human history, outlasting all stone monuments ever carved upon planet Earth. The path it blazed through the heliopause has permanently opened our minds to the true complexity of the wider universe surrounding us. Future space missions currently envisioning faster interstellar travel will build directly upon the foundational discoveries made by this single probe. We have learned that interstellar space is not an empty desert, but a vibrant ocean filled with motion, energy, and weather. Understanding these cosmic dynamics strengthens our appreciation for the unique planetary shield protecting life on our fragile homeworld. Every night, when you look up at the starry sky, remember that our ambassador is out there right now, pushing limits. Operating on less electrical power than a tiny nightlight, it proves that great achievements require vision rather than immense resources. The dedicated engineers and scientists who maintained this mission for nearly half a century have gifted humanity an incomparable legacy. Their patience and ingenuity demonstrate what humanity can accomplish when we unite our talents toward peaceful scientific discovery. As the craft approaches its momentous one-light-day milestone, we stand at the threshold of an unprecedented historical achievement. 24 hours for light to travel from Earth to our probe highlights the truly colossal scale of our cosmic neighborhood. Yet, despite this unfathomable distance, the unbreakable bond between our home planet and this distant messenger remains fully intact. We are witness to a historic moment that no prior generation of human beings has ever lived to experience or celebrate. This small machine carries the hopes, dreams, and collective curiosity of billions of human souls who have ever lived on Earth. It reminds us that our true destiny lies not in conflict, but in reaching outward to explore the wondrous universe around us. Every plasma wave detected, every byte of telemetry transmitted, brings us one step closer to understanding our place in the cosmos. The journey of this venerable explorer teaches us to embrace the unknown with courage, wonder, and unyielding optimism for tomorrow. Though its electrical voice will someday quiet, its quiet journey through the dark star fields will never truly come to an end. It will sail onward through the silence of space, a shining beacon of human intelligence floating among the ancient stars. We honor the visionaries who built it, the engineers who saved it, and the cosmic voyage that continues, inspiring humanity today. As we close this chapter on interstellar discovery, we realize that every ending in science is simply a new beginning waiting ahead. The edge of our solar system is not a barrier that confines us, but a gateway, inviting future generations to explore further. New technologies will eventually build faster starships capable of catching up to our ancient ambassador and surpassing its record. Until that day arrives, Voyager 1 remains our sole living witness to the profound mysteries of the vast interstellar ocean. It carries our spirit into the dark void, proving that human curiosity knows no physical boundaries or temporal limitations. We are fortunate to live in an era where we can listen to the faint heartbeat of a machine sailing between star systems. Let this extraordinary journey inspire you to look up at the night sky with renewed wonder, awe, and endless curiosity. Never stop asking questions, never stop reaching toward the unknown, and never forget our humble origins among the stars. Together, we will continue unraveling the deep secrets of the cosmos, one remarkable discovery at a time. The universe is calling to us, and our greatest cosmic adventures are only just beginning to unfold before our eyes. Thank you for joining us on this unforgettable voyage to the absolute edge of everything our species has ever known. If you love deep space mysteries and science discoveries, make sure to subscribe and turn on all notifications now. Share this video with fellow space enthusiasts who appreciate the incredible stories of human exploration beyond Earth. Leave your thoughts in the comments below about what surprised you most regarding this immortal interstellar space mission. We will continue bringing you the most groundbreaking space news and cosmic secrets from across the infinite universe. Until next time, keep exploring, keep dreaming, and keep looking up at the majestic stars above our heads. Farewell from the edge of the solar system, where Voyager 1 carries our eternal curiosity into the infinite dark void.